Analyze the given graph of concentration versus time. Observe how the concentration of reactant X decreases at regular intervals. At t equals 0 minutes, 10 equals 1.0 molar. At t equals 20 minutes, 10 equals 0.5 molar. The concentration is halved, meaning the first half-life is 20 minutes. At t equals 40 minutes, 10 equals 0.25 molar. The concentration is halved again, meaning the second half-life is also 20 minutes. At t equals 60 minutes, 10 equals 0.125 molar. The third half-life is also 20 minutes. Identify the reaction order. Because the half-life, T1/2, remains constant at approximately 20 minutes regardless of the starting concentration, the reaction exhibits first-order kinetics with respect to reactant X. Apply the integrated rate law for a first-order reaction. According to the AP Chemistry equation sheet, the integrated rate law for a first-order reaction is ln T ln rho equals Kt. By isolating ln A T, we can rewrite this in the slope-intercept form. Y equals mx plus b ln x. T equals Kt plus ln x 0. Y equals ln x. Tx equals t. Time. M equals k, the slope of the line. B equals ln x 0, the y-intercept. Conclude how to determine the rate constant. K. Plotting the natural logarithm of concentration, ln x, versus time, t, will produce a straight line. The slope of this line is k, so determining the magnitude, absolute value, of the slope yields the rate constant, k. This corresponds to option A. The correct answer is option A. Plot ln x versus time and determine the magnitude of the slope.